Another interesting question which is here, and I received this question from different students sending in my inbox, knowing on how they can solve it, and ah, come on, guys. So now this question, the information they gave you, it wasn't enough. I believe the people who wrote this paper, I think this came in 2022. I believe the people who wrote this paper, they gave them the change in x and the change in y. So I have my change in x, which they gave them in the final exam. So the change in x is there, and the change in y is there. So this is the question. So the question is, a particle floating on a disturbed water surface undergoes a motion represented by the following diagram. Given that the frequency of oscillation of the particle is 8.00 hertz, that's the diagram we can see, guys. Then the first question is, calculate the speed of the water wave. Then 2 is saying, how long does it take the particle to perform one complete oscillation? One complete oscillation. Okay, so now we are interested in finding the speed. One thing we have to remember is that the speed of wave is given by frequency times lambda. So what is lambda? I have the frequency, definitely I know that is 8, but what is lambda? Lambda is the change in x in this case. The distance between two successive crest or trough is the wavelength. Okay, so here from this point, that is my crest, that is my crest. The distance in between, that is the wavelength. Even if I can get from that point all the way to that point, that is one wavelength. So now the change in x at that point is what? That is the lambda. Lambda is measured in what, meters, so it is the same as the change in x in that case. Okay, so what is change in x? Change in x is 40 centimeters. We have to convert this to meters, so I'll say 40 divided by 100, which is 0.40 meters. Okay, so I'll say v will be equal to 8 times the lambda is 0.40. So v will be 0.40 times 8. That should be 3.2 meters per second. That's 2 marks. We are done. The next question was, how long does it take the particle to perform one complete oscillation? One complete oscillation is just coming from this point reaching at that point, meaning the wavelength is the same. Okay, so now in this case we want to find the period. The period is same as time. So how do we have the frequency already, guys, here? So period is given by 1 over frequency, 1 over 8. So it took about 0.125 seconds to complete just one cycle. That is it for this question. So now this question you are having, you had some challenges because the information wasn't enough. You didn't have lambda, but this was the information which was given in an exam. So the change in x was given to be 40 centimeters, the change in y was given to be 15 centimeters. But now in this case, in a case where you have been asked to find what is the amplitude, the amplitude is change in y. So in this case you say the amplitude is 15.0 centimeters. Okay, yeah.